Okay, so again, I just wanted to give a quick-ish review on unit circles. The first thing we've already talked about is our location on the unit circle with coordinate points. So if you put a coordinate point on here, and again, our unit circle, before I start that, realize our unit circle is just a circle that is centered at 0, 0 with a radius of 1. Okay, when you're using the unit circle, you're always going to start, at least when we're talking about angles, on this positive x axis. So every angle we get, we're going to measure from there. So if I have that angle right there, we usually call it theta. Theta is just an unknown variable, and we usually use that for angles. So if I have that angle right there to be, say, 65 degrees, we've already talked about how you can find this point right here by using cosine theta, sine theta. So this location point, we could use our calculator, do cosine 65, get a decimal point, or a decimal, sine 65. And we'd have our location right there. All right? Also realize that if it's not just a unit circle, if it's any circle, if we went back here and said, oh, this is a radius of, say, 7, same angle, we'll just change that to a radius of 7, that all it changes in our location formula is we multiply each of these, we scale it by 7. So that location point now would be 7 cosine 65, 7 sine 65. All right? So that talks a little bit about location. Also keep in mind how each of the quadrants is going to give you different signs, as in positive and pluses and minuses, positive and negatives, for each of the cosines and sines. So, for example, in quadrant 1 here, what are both cosine and sine? Are they positive or negative? They're both positive, right? So in quadrant 1, they're both positive. So keep that in mind as we work around here. Okay? If I go over here, and I have this angle, and we have cosine sine, which of those is positive, the cosine or the sine? The sine is positive because we're going upwards, right? So if you think about this, cosine theta, sine theta is just that point right there. Oops. The cosine, because it's the x, is going in a negative direction, so that'd be negative. And the sine is positive because it's going upward. All right, the next thing I want to talk about was reference triangles. Okay, reference triangles are how we're going to solve in the unit circle. Okay, usually we have either a point. Basically, what we usually have is an angle. We have an angle that will give us the point based on our terminal side. So let's just use an angle of, I don't know, Cedric, give me an angle. 58. So we're going to go 58 degrees. That's Cedric's angle. So 58 degrees from the initial side right there would be in which quadrant? It'd be the first quadrant, because as we go around here, we start here, 0, 90, 180, 270, 360. So 58 is just about 60 degrees. We'll just go about right here. It might not be perfect. We'll call this 58 degrees. Okay, we can draw a reference triangle. Now the reference triangle we're going to draw every time. we're going to draw it to the x-axis. So that's our reference triangle we're going to draw. That's the triangle we're going to use. We know it's 58 degrees. We also know since this is a unit circle, it has a radius of 1. So if I wanted to find the other two sides of this triangle, x and y, how could I solve for x or y? Just use trig functions. Use trig functions. I would use cosine for x and sine for y. Okay, and use that 1 as a hypotenuse. So we use trig functions. Now the thing about a reference triangle is we can have the same reference triangle because we're always going to the x-axis. We can have the same reference triangle in each quadrant. So I can do something like this. That could be the mirror image. It could be reflected across the y-axis. So just take this triangle and reflect it over here. And it could be the same triangle, 58 degrees. And I can continue that in all 4 quadrants. Okay, now, if I'm having that reference triangle, my angle to the x-axis is 58, but remember, I'm always measuring my total angle from this positive x. So what would that angle right there be? Now Cedric's regretting using 58. What would that angle be? What's that? 122. Okay, because we subtract from 180. So that'd be 122 degrees. What that means is that the reference triangle we're going to use for the 58 is the same reference triangle we would use for the 122. It's also the same reference triangle we would use for, actually, can anybody think about it in this quadrant right here? What would be that reference triangle right there? What would be the total degree?
238.
238. So it's the same reference triangle we would use for 238 if we went there. 180 plus 58. And it's the same reference triangle we would use for this one right here. What would be that angle?
302.
302. We did 360 minus. So these angles right here, all 4 of those, we would use the same reference triangle for. Okay? So if I did sine 58, sine 122, sine 238, and sine 302, we would have virtually the same answers. What's the only thing that would change? The sign, as in whether they're positive or negative. Okay? Because if I look at, say, this reference triangle right here, that one, this adjacent side is positive and the opposite side is positive. And the hypotenuse is positive. So sine, cosine, and tangent are all positive in that quadrant. Okay? If I go over here, what's negative? What side is negative? The x side. Okay, the x side's negative, which is our adjacent side, which is going to give us the cosine as a negative number. So, for instance, if I did cosine 58, I would get a number. If I did cosine 122, I'd get the same number, but it'd be negative. If I do cosine 238, same number, would that be positive or negative? Negative, because my adjacent side here is still negative. And cosine of 302, would that be positive or negative? Positive, because that adjacent side is positive. And we could use the same thing. So the reference triangle is really important because you get 4 values. Okay? One shortcut, which you might kind of go over your head right now, but we're going to say, is that we have a little shortcut to remember what's positive and negative. In quadrant 1, all are positive. So sine, cosine, tangent, all positive in quadrant 1. Okay, in quadrant 2, what is positive? The sine. Is sine the only one? Yep. So in quadrant 2, the sine is positive, at least for the 3. We could talk about cosecants and secants later, cotangents. But the sine is positive in quadrant 2 because that opposite side is positive. That adjacent side is negative, so that's going to make our cosine and our tangent negative. What about quadrant 3? Quadrant 3, sine, cosine, tangent, which one of those is positive? Tangent. Yeah, our tangent is the only one that's positive in that quadrant because we have both our opposite side and our adjacent side are negative. So when you do opposite over adjacent, it becomes positive. And then in the quadrant 4, what's positive? Cosine. So there's a lot of little ways you can remember those. I know a lot of teachers teach ways to remember those. I usually don't so much because I kind of want you to use that reference triangles all the time in order to figure that out because it helps you with your trig, opposite, adjacent, hypotenuse. But if you are one that likes little ways to remember things, if you go from 1 to 4, you can say all students take calculus. And if you do that, you remember that it's all students, sine, take, tangent, calculus, cosine. Okay, questions about reference triangles and the signs within the reference triangles. So the next thing here is, okay, now we have the idea of reference triangles, how are we going to use them? And we're going to use them to solve problems, especially without a calculator. If you have a calculator, cosine 135 is just a few buttons away. But if you don't, and you can't, and we usually don't want to always be able to use a calculator, that we want to be able to solve this without a calculator. Now the key here is to actually solve and get a number, like an answer for cosine 135. Okay, actually there's really two things you're going to get when you want to solve without a calculator. The first thing is an answer. The second thing is another angle that matches the first one. We'll work on both of those. But to actually get a number answer, numerical value for cosine 135 or a cosine of anything, you're only going to be working with the triangles that are special. Because those are the ones that we have a side ratio hopefully memorized for. Okay, if you don't have them memorized, I'll draw them right here. I would make sure you have those in your notes. Your 30, 60, 90 right triangle always has a short side, a medium side, and a long side, hypotenuse. Okay, if we have the short side, and the most basic short side would be 1, what do we have from there? Let's jog our memories here. Okay, so one side is double. Which side is double, the medium or the long? The hypotenuse is double the short side all the times in a 30, 60, 90. So if that's 30 degrees, 30 degrees is going to be across from the short side. 60 degrees is going to be across from the middle side. Hypotenuse is across from the 90-degree angle. Okay? And then what would the medium side be according to the 1? Square root 3. It's 1 times root 3, but that's your shortcut. So if you have a 30, 60, 90 right triangle, the short side is a number. You double it to get to the hypotenuse. You multiply by root 3 to get to the medium side. For our trig values on the unit circle, we really don't need all of those. Okay, we don't need all of those. Okay. The second triangle is our 45, 45, 90 right triangle. That one's actually even easier. It's an isosceles right triangle. So we have this picture right here. Those are equal. Both of the non-right angles are 45. So our base is to call our two equal sides 1. And then what would our hypotenuse be? Root 2. So 1 times square root 2. So in a 45, 45, 90 right triangle, we can always go the legs of the isosceles triangle times root 2 give us the hypotenuse. Okay, so we're going to need those. Let's go to our problems here. So if I wanted to find what cosine 135 would equal, go ahead.
Okay, so if you have a side length of like 4 on the 45, 45, 90,
Okay.
it'd be 4, 4, and then that would be 4 times root 2.
Exactly.
Okay.
Exactly. Okay, so if we have cosine 135, step 1 is to find that 135 degree angle from our starting side, positive x-axis. So which quadrant would 135 be in? It'd be in quadrant 2. So 135 would be something like this. That's 135. Okay, now we have to draw a right triangle, a reference triangle. Okay, so we always draw the reference triangle to the x-axis. So we're just going to drop a side down to make a right angle there. Okay, again, we're looking for cosine 135. What would our angle be here to form that right triangle? 180 minus 135, which is 45. So now we could put a 45 degree angle there. Well, once we have a 45 degree angle there, now we just use this triangle. So those triangles are congruent. What would this side right here be? We're really not using the unit circle anymore, by the way. We're just using a circle. So if we have a 45, 45, 90 right triangle, we can put this side as 1 if we like. If that's 1, what's this side right here going to be? What's this opposite side going to be? 1. And this would be square root 2. So cosine of 135 would be adjacent over hypotenuse. So what would cosine 135 be? 1 over root 2. Okay, the only thing you have to be careful of here is the sign. Is it positive or is it negative? So we look back, we use adjacent side. Our adjacent side is that positive or negative? That's negative. Our hypotenuse is positive, so this answer would be a negative 1 root 2. Mason.
So the 1 isn't it, if it's unit circle, 1 to 1 take all the way to the side?
It would, but we're not going to use the unit circle idea anymore. We're just going to say that's special right triangle, because it really doesn't matter what size the circle is as long as we can solve it, right? Yeah, so we're not really using it. It's not really a unit circle anymore, but we just solve for cosine 135. Yes?
So we can just decide we don't want to use the unit circle?
Well, it's still, we started with the unit circle, but once we have that triangle, we can just scale it out. So one of the questions I'm getting right now is, well, we kind of changed it. We're not using the unit circle. Well, we started with the unit circle. We drew a basic circle. But the thing is, because these are the ratios of sides, the ratios of these sides aren't going to change at all. Right? I mean, for instance, if we kept it a unit circle, then this would be 1, and this would be 1 divided by root 2. Okay, so there's a lot. I mean, we can put numbers in there all we want, but the ratios is what the cosine is just a ratio, so it doesn't really matter how big our circle is. That cosine will be the same answer. That makes sense? All right. So if we want to do sine 300, then let's look at that. All right, let's go ahead and do sine of 300, and then we'll do tan 210. We'll finish this out quick. quickly here. So sine 300, what quadrant are we in?
4.
We're in quadrant 4. It would be somewhat like maybe that. That would be 300 degrees. We draw the reference triangle to the x-axis. What would our angle right here be? It'd be 60 degrees. A good hint here is that if they just give you one of these without a calculator and want you to come up with an answer, it's going to be one of the special right triangles. So it's either going to be 45, 60, or 30.
So it's not, there's 30.
Well, if it's not, there's probably going to be a different way to solve it. Okay, so that's 60 degrees. So we can use our special right triangle here. Since that's 60, our short side would be right here, be 1. What's this hypotenuse going to be? 2 root 3. We're starting at 60. Now it's just a trig problem. So sine is what? Opposite over hypotenuse. The opposite side is root 3. The hypotenuse is 2. So your answer would be root 3 over 2. Again, sine is opposite over hypotenuse. Okay, now double check that it's positive, the positive or negative is correct. Sine, you use a shortcut. All students take calculus, which means that cosine is the only positive in that quadrant, so sine has to be negative. That's your shortcut. Okay. Tangent 210, let's work on that one. Okay, 210, what quadrant's that in? Third. So 210 would be something like that. Okay, what would our degree right here be then? 30 degrees right there. 180 plus 30 is 210. Okay, so I draw that out. I have my special right triangle. So I have 1, 2 root 3. That just came right from this picture right here. Now we have tangent of 210. Okay, so tangent is opposite over adjacent. So what's the opposite side of 30? 1, the adjacent side. Root 3. All students take, so tangent is positive in that quadrant, so this stays positive. Okay, the only thing that, and I don't want to really focus on this because this is not part of the concept, it's just part of simplifying, is that you're not supposed to have these square roots, the radicals in the denominator, but for right now I'll just leave them because I just want to make sure we understand the concept. Tom?
You have tan not in the third quadrant.
Say that again?
You have tangent not in the third quadrant.
Tangent is positive in the third quadrant.
Can you not have it in the third quadrant?
Can you have tangent in other quadrants? Yes, you can have them in other quadrants. Yes, and if they're in the other 3 quadrants, they would be negative. I'm sorry. If you had them in this quadrant, quadrant 1, everything's positive, so tangent would be positive here, and tangent's positive here. In these 2 quadrants, 2 and 4, tangent's negative. Okay, last one would be, So last one is, this one's kind of working backwards a little bit. Okay, on this one we're actually going to use, we're not even going to really use the unit circle, we are kind of, I'll show you what I mean. When you see cosine of an angle, so we should know now, this is asking for an angle. So cosine of some angle is root 3 over 2. Okay, what's the first triangle you think of here? 30, 60, 90. So if I draw a 30, 60, 90 right triangle, that wasn't good. That's 60. That's 30. Okay, which of those angles would give you a cosine of root 3 over 2? 30. Okay, because cosine is adjacent over hypotenuse. 30 gives the adjacent side of root 3, hypotenuse of 2. So 30 degrees is our answer. but it's not our only answer. This is where the unit circle comes into play. Okay? Cosine is positive. This is a positive answer. Positive root 3 over 2. And cosine is positive in this quadrant, which is our 30-degree angle. So if I drew, let me use a different color here. So if I draw a 30-degree angle here, that is a positive cosine. What other quadrant is cosine positive in? Quadrant 4. So that means that our only other answer that would work, that was bad, would be our 30-degree angle right there. And what would that angle be overall? 330. Be 360 minus 30. So there's our two answers for, oh, not 333. 330.
You have to get both answers to get it right.
Yes, you need both answers. If it were a negative, if I made this a negative root 3 over 2, then your answer would be the true triangles in these two quadrants. So it would be 150, 180 minus 30. So it would be 150 and 210 would be your two answers. I told you a second ago, or a few minutes ago, that really there's two types of triangles you can solve for without a calculator. It's a 30, 60, 90, or it's a special right triangle, right? And then you could do one that's kind of solved without a calculator. Now let's say we have just a random one. Let's say we have cosine 162. We can't do that without a calculator. Okay? But what we can do is we can find another angle that's equal to that angle. Tom?
Can't you take that and you make your line?
So you want me to make my reference triangle?
Yes.
So 162 would be about right here, we'll say.
So then you can find 180 minus 162.
Okay, which would be
The hypotenuse of
18.
one, and then you do sine.
I'm going to stop you right there. So you're right. You could figure that out.
Oh wait, but then you need.
But then you need the calculator to do the sine of 18 equals x over 1, right? So realistically, you need a calculator. When they ask you these types of problems, they say no calculator, like don't touch a calculator, and I don't give you trig tables. We're just going to have that. We're just going to figure out what other triangle, what other angles it's equal to. So usually it'll say cosine of 162 equals, say, cosine of x. Solve for x. And like you just figured out a second ago, you said that there's always two answers, right? So the first thing would be to say, okay, is cosine 162, is that positive or negative? It's negative because we have an adjacent side. That's negative. So this is a negative number right here. What other quadrant gives me the cosine that's negative? 3. Quadrant 3. So I'm just going to draw the same exact triangle reflected down there. And then 18 degrees is going to go right there because they're congruent. So what would x be then? What's the other angle that goes all the way around? It'd be cosine 198. So cosine 162 equals cosine 198. And that's when I say we're going to solve without a calculator, kinda. It'll get a little bit more difficult. Like instead of saying cosine equals, it might say cosine equals a sine. But if you get those concepts right now, you should be okay for almost all of our unit circle things.